Welcome back. So let's talk about the different types of volcanoes because there's a number of them, and let's talk about how those different volcanoes erupt. Not all volcanoes are the same. Not all eruptions are the same. So there are factors when determining the volcano eruption type, and we touched on most of those already, but to kind of get into how that explains volcanoes and eruption types. But again, volcanoes vary greatly. Size, some are taller, some are wider, some are explosive, some are gentle. Different shapes, flat, more cone-shaped and steep. Some are just big lines. And then composition, what the material is made out of that's erupting out of Earth. So viscosity, how flowy the magma or lava is, and volatile content, how much dissolved gas, how much gas is trapped in the magma or lava. Those are still the primary controls of volcano type and eruption explosiveness, which is tied to silica content. So again, going back to this chart, it's a very important chart. The more silica, like quartz, that is in the melted material, the more viscosity it has, meaning the more sticky and slow running it is, the more gas it traps, the more explosive it is. The less silica that's in the molten rock, the lower viscosity, meaning it's very runny. Higher viscosity, cold, sticky, slow moving. Not cold, I'd say, just sticky, slow moving. Low viscosity, very flowy, very runny like water. So low silica content, for instance, low in quartz, molten material. Low viscosity, very flowy. Low volatile content, because it's a very thin, flowy fluid, the gas doesn't get trapped in there. Therefore, very low on the explosivity. So, depending on what material is being melted, most commonly determined by what boundary it's near or hotspot activity. So, determining what the molten material is determines its characteristics of the magma and lava, which will make different types of volcanoes. So you have big fissure eruptions that are just kind of linear. The shield volcanoes, both of these are low silica lava that's coming out of here, so low viscosity, so very runny, so the material runs in very far off in many directions. It doesn't really build up steep volcanoes because the stuff is flowy and running. It just kind of spills out. These are gentler eruptions. Fissure and rift volcanoes erupt in an Icelandic style eruption. Shield volcanoes erupt in a Hawaiian style eruption. So then you start to get into the kind of intermediate and acidic magma and lava, kind of medium silica content, medium viscosity, medium volatile, medium explosivity. In some ways, it will form small little cinder cone volcanoes, which have a strombolian eruption typically. And then you get up into stratovolcanoes, sometimes called composite volcanoes, and they can either erupt a Vulcanian eruption, a Pelian eruption, or a Planian eruption. Those are pretty close to one another. And then there's actually one more volcano type, supervolcano, that explodes supervolcanically. So, in order of increasing degree of explosiveness, on that chart you just saw, we have Icelandic eruptions and Hawaiian eruptions, both basaltic magma and lava, low silica content, low viscosity, very runny, not a lot of trapped gas. When these types of eruptions occur, it's very flowy. It doesn't explode out. A lot of lava comes out. And then in increasing explosiveness, you start to get into strombolian, Vulcanian, Pelian, and Planian. The most explosive, with a little asterisk, the most explosive common type of eruption. Because there's one more that we can probably put on that list, and that would be a supervolcano, and that doesn't happen too often. So how we rate explosiveness is on the Volcanic Explosivity Index, the VEI. It's a relative measure of the explosiveness of volcanic eruptions. So it's just comparing one to the other. It's dependent on how much. So when we're calculating the VEI of an eruption, we usually do so afterwards because it's a calculation of how much volcanic material is thrown out and to what height. Additionally, how long the eruption lasts and other qualitative observations. Not quantitative, that's like numbers and data, but other qualitative observations, kind of talking about this was a gentle eruption or mega colossal. Qualitative is more descriptive. All this is used to determine the explosivity index, the VEI. It's a scale from 0 to 8. It's a logarithmic scale, just like the Richter scale, that we use to measure magnitude of an earthquake. So it's a logarithmic scale. So each step from 0 to 1 is not just a little bit more. It's 10 times more material, 10 times the height, etc., etc. So it's logarithmic from 10 times to the next. So again, an increase in 1 on the scale indicates an eruption that is 10 times as powerful. So just to give you a little visual, so this is the VEI from 0 to 8 and the relative amount of material that gets pumped out onto the surface and into the atmosphere. So when we start to get to 1 compared to an 8 would be this big thing here. So you can see how each of these is 10 times bigger in volume, 10 times bigger in volume than the previous one. So yeah, over here, Icelandic or Hawaiian eruptions, they'd be 0 to 1. Strombolian eruptions 1 to 2. Volcanian eruptions 2 to 3. Palaean eruptions 3 to 4. Plinian eruptions can range from 4 almost to 8, and then once you get into this realm, you're dealing with super volcanoes. So over the last 10,000 years, how many times have these things happened? Well, Icelandic and Hawaiian style eruptions common at rift volcanoes or shield volcanoes many times. Strombolian eruptions smaller on the explosivity scale many times. Volcanian up over 3,000. Palaean up over 800. And when you start to get into the Plinian, these get further, less and less and less the more explosive that you get. And in the last 10,000 years, there's been no super volcanic eruption. So more a little bit on super volcanoes later. So those are the styles of eruptions. And now let's talk about the types of volcanoes. So, and we'll again go from kind of low explosivity to high. So first starting off with shield or fissure volcanoes. The magma and lava is very basaltic. It's gently flowing lava, non-explosive eruptions. So when these erupt, a lot of lava, not a lot of explosions, very gentle eruption. The lava, if it comes into contact with anything, a house or car or whatever, obviously those houses and cars are gone, but it's not explosive, and, it doesn't necessarily surprise you. Lava's coming. So usually a low death toll associated with these types of volcanoes, but a higher property damage with these. Because lava flowing, here comes some lava. Now I'm out of the way of the lava. So it's not usually a lot of human deaths. Shield volcanoes, they're the largest volcanoes in the world, but just because they're the largest doesn't mean anything about how explosive it is. Because the lava that's coming out is very thin, low viscosity, very flowy, it's just like pouring water on your kitchen table. It's just going to flow out in all directions. Well, that's what happens here. This basaltic lava kind of just flows out in all directions. It cools and hardens. You get another eruption, basaltic lava flowing out in all directions. Another eruption. So they kind of build up over time with different eruptions. So they're very wide. They're much wider than they are tall. So they're wider than they are tall. Fissure volcanoes can be even just a few meters wide, but can be, a good kilometer plus long, a mile plus long. And they cause large flood basalts, also very runny. So kind of coming out of this big crack, this big fissure that's like a mile plus long, flowing out in all directions. These types of volcanoes are common at hot spots underneath the oceanic crust and divergent plate boundaries or continental rifts. The Hawaiian Islands, shield volcanoes. Iceland, fissure volcanoes. East African Rift fissure volcanoes. So, yeah, this doesn't give you the sense of how wide these are compared to how tall. Again, and with the rift volcanoes, these can be mile plus long. So effusions of molten basaltic lava that's low viscosity, low gas content, low explosive lava that flow from long parallel fissures is what Icelandic volcanoes are, or fissure volcanoes with an Icelandic eruption style. And then shield volcanoes, emit fluid lava flows from a volcano's summit and radial fissures that might radiate out. And a shield volcanoes erupt with a Hawaiian eruption style. So here's an Icelandic style eruption from a rift or a fissure volcano. So a long crack in the ground where the stuff is just kind of coming out and flowing off in each direction. So Iceland sits right along a divergent boundary. So Iceland is literally being ripped apart, creating these rifts. And this is an old volcanic fissure. This is Iceland being ripped apart. So yeah, coming back to, so on one side is, if this is the divergent boundary that's running through Iceland, this is the Eurasian plate, this is the North American plate. So a Hawaiian style eruption, again, there's usually a center pit of where the lava is coming out, very flowy, forming shield volcanoes, not very explosive. Every once in a while you'll get a good jet of lava coming out, but overall the volcano is not explosive. Some examples where we find shield volcanoes are Mauna Loa in Hawaii. So here's Mauna Loa. You can see how wide it is compared to how tall it is. So it's much wider than it is tall. Kilauea is another shield volcano on Hawaii, much wider than it is tall. Now they are tall, but they're definitely characteristic of being much, much wider than they are tall. Mount Rainier, which is a stratovolcano, compared in size. Now, again, size doesn't really tell you much. Just because Mauna Loa and Kilauea, these are shield volcanoes, because they're big doesn't mean they explode, because they don't. However, Mount Rainier is a stratovolcano. This will explode much more violently than either of these ever will, because this is a stratovolcano in Washington State. This is just showing you comparisons of heights and sizes of these things to show you that just because they're big doesn't mean they have to explode. So here's Kilauea. You can see, as far as you can see, these are all old lava flows. So these are shield volcanoes. So let's take a pause here. So we talked about fissure and shield volcanoes. When we come back, we'll talk about cinder cone volcanoes and stratovolcanoes, kind of the two more additional types of volcanoes, and then we'll finish this section with one more type of volcano. We'll talk about supervolcanoes. See you back here in just a second.